In this exercise, we want to draw arrows to represent additions and subtractions on a number line. The first one says 3 plus 8. So we actually want to always start from 0 when we do this. And we want to go to the right if it's a positive number and go to the left if it's negative. The first number is 3, so that's positive. So I'm going to draw an arrow with a length of 3. And I want my arrowhead here to stop on the number 3. Then from there I want to add 8. So I'll put a new arrow with a tail at 3 and then have it have a length of 8. And that takes us to 11, which is the final answer to that addition. When we're doing a subtraction, it's a little bit tricky to do because we don't want to actually have our arrows overlap. So my first arrow, the initial one, goes from 0 to 7. Then I want to subtract. So rather than going to the right, I'm going to go to the left. But we don't want to have the arrows overlap. So I'm actually going to move up here. And then I'll go back 4 spots to 3, which is the answer to the question. These types of problems are one-dimensional. So only the leftness and rightness matters. It doesn't matter whether we move our arrows up or down. This one says 2 plus 5 plus 4, so we're going to go over 2, then over 5 more, and then let's add 4 more, which takes us to a final location of 11. 12 minus 3 minus 5. Okay, we'll go to the right 12. Subtract 3. And then subtract 5. It takes us to 4. Here we have negative 5. So we're going to want to go to the left right off the bat this time. And from there, subtract 6 more. Takes us to negative 11. Here we'll go backwards 11 spaces, and minus a negative is a double negative, which means we won't subtract, we'll add, and then add 4, taking us to negative 7. Now, tracking simple additions and subtractions with arrows will lead us into a discussion of what mathematical vectors are. Vectors are a really important concept in physics, and just simple numbers being added and subtracted actually aren't technically vectors. But as we'll see, there are certain types of quantities in physics that use what are called vectors, and they are represented as arrows in mathematics. Now let's try to represent these same ideas with a word problem and a formula. Say you decide to go rock collecting on a beach. You bring 4 of your favorite rocks in a tin can. Throughout the day, you place 6 new rocks in the tin can. How many rocks do you have in the can at the end of the day? Now, it seems like just a simple question from grade school, easy to answer, but it actually is an example of a concept that we'll use in physics all the time, maybe one of the most important formulas in science of all. And that formula is the initial plus a change equals the final. Now, from the wording, we have to extract what represents the initial amount, what represents the change, and what represents the final. Typically, we'll be asked to find one of these 3 things, and the other 2 will be given. So we have to extract from the wording which of these is given and which is which. So the 4 rocks that you bring to the beach in your can, that's going to be the initial number of rocks. So let's put that here, 4. Now how about the 6 rocks that you picked up while you were there? Is that the change or the final? It is, of course, the change. And it says, how many rocks do you have in your can at the end of the day? So they're asking us to find the final here. So we plugged in what we knew. We want to solve for the unknown to reveal that you have 10 rocks in your can at the end of the day.